In section 6.2, we are adding and subtracting rational expressions. So we're going to add and subtract fractions just as you have in the past, which means we need to have a common denominator. If we already have a common denominator, it's pretty straightforward. We're just going to add or subtract numerators, and the denominator will stay the same. For example, if we have a over d plus b over c, if the denominator is the same like it is here, we'll just add the a and the b, and the denominator d will stay the same. Keep in mind, though, our final answers must be reduced, which means that we have to factor and cancel at the end when we add or subtract fractions. So we're going to 1, add or subtract, and then 2, we will factor and cancel. We will worry about getting a common denominator later. The first couple examples will already have a common denominator. So, for example, on A, we have 4x over 11 plus 3x over 11 plus x over 11. We have a common denominator of 11, so the 11 on the denominator will stay the same. Then we can just add all the numerators normally. So 4x plus 3x is 7x, plus one more x is 8x. Now notice that there is nothing in common between the 8 and 11 on the denominator, and this cannot be reduced, so that is our final answer. Moving along to B. Notice the denominator is the same. It may look a little bit complicated, but it is a common denominator. So the denominator of x plus 3 will stay the same because it's a common denominator. And then we can just add our numerators as we did in the last one. Remember, though, that adding and subtracting terms means we can only combine like terms. So on this one, we have a 2x and a 5x that can be added to give us 7x. And let's see what else we have. We also have a 8 and a negative 3. Well, 8 added to negative 3 is positive 5. Now, we have to be careful. We've added and subtracted. Is this reduced? Meaning, can we factor or cancel anything out? In this particular one, there is nothing that we can factor or cancel out, so we are done. But that is something we have to begin to think about. On this next one, it's a little bit different because it is subtraction. We do already have a common denominator of 5y, so that common denominator will stay the same. So when we add or subtract, it will still be 5y. But when we stick a subtraction sign in front of an entire fraction, it means that that has to be distributed to everything on the fraction that follows. So it means that we actually have a negative 2x minus 7. And then let's cancel out the negative sign because it's already been used and distributed to the entire fraction. Then we can just add normally. Well, notice then we have our like terms, a 7x and a negative 2x, which is 5x. Also, we do have, let's see, a positive 7 and a negative 7, but those will just cancel out. So that leaves us with our 5x over 5y. Notice here's a good example of something that is not reduced. So we can reduce this. So notice there's a factor of 5 on the top and the bottom that can be reduced. So we can divide out a 5 from the top and the bottom, which in a sense just cancels them out and leaves us with our final answer of x over y. So let's give a look at another one to see if we've got this down. So again, we've got a fraction in which there is subtraction, which means that that subtraction symbol has to get distributed to the entire top of the second fraction. So that means it becomes a negative 3x and a plus 2. Again, just like before, let's cancel out the negative because now it's been used. The common denominator is already x plus 5, so it's going to stay the same. It's going to stay as an x plus 5. All we have to do is add and subtract normally now. So we have a 5x and a negative 3x, which when added together will give us 2x. We also have, let's see, an 8 and a 2, which when added together is going to leave us with 10. Again, this looks like we're done, but when you're adding or subtracting, we have to reduce at the end, which means we have to make sure everything has been factored and canceled. So notice there is something small we can factor. We can factor out the numerator here in our final answer. Notice we've got a 2x plus 10. There's a GCF of 2, so let's factor out a 2, which will leave us with x plus 5. Which notice there already was an x plus 5 on the denominator. So we can cancel out that common factor of x plus 5 on the top and the bottom, which leaves us with just the number 2, or 2 over 1, which is also 2.